Welcome to all in exam days. This is a thermodynamics and we are here for Carnot engine. Here we will see what is actually a Carnot engine, how it is different from the real engine, and what are the efficiencies related to the Carnot engine, how to find the efficiency, how to find the work done of the Carnot engine, and what amount of heat is accepted or rejected by the Carnot engine. Also, we will see the questions that are related to the Carnot engine and the Carnot engine efficiency. So Carnot engine is actually an ideal reversible engine that expands between the temperature. So we can say that they expand between the temperature T1 and T2. So where T1 is your source temperature and T2 is your sink temperature. Now question arises, what is source and what is sink? See, source is what a heat reservoir, and that heat reservoir at certain temperature we consider it at T1, and from which the engine is drawing heat. So it is supposed to be the source which has infinite thermal capacity. So you can say any amount of heat you can withdraw from the that source without changing the temperature. Means temperature remain constant for that source and also for the cylinder that you are using in this Carnot cycle. So what kind of cylinder? Cylinder is a main part of the engine that has some conducting base and insulating walls, and it is fitted with a insulating frictionless piston. Okay, if I show you, it looks like this. Like this is a cylinder with a non-conducting walls, isn't it? Or insulating walls, but the base is conducting. Base is conducting, and walls are insulating. And in that, what happened? Your piston is there, and piston is moving freely. You can say frictionless piston. Okay, so this is what the source. And what is sink? Sink is all about, you can say, cold reservoir. Okay, one is hot reservoir, another is cold reservoir. So it is a reservoir at lower temperature, you can also say, as compared to the source. So T2, if I say T1 is the temperature for source and T2 is temperature for sink, then we can say T2 is less than T1. Okay, so this is the amount of heat, this is sink is the amount of heat is rejected by the engine. So it is also a infinite thermal rejecting capacity or thermal capacity. So any amount of heat can be added without changing its temperature. Okay, so this is all the things about source and sink. Now another is we are going to use insulating stand, and in that insulating stand the base of cylinder is attached with the insulating and the working substance get isolated from the surrounding. Okay, so all these things is what we call working substance of an ideal gas inside that cylinder. So ideal gas is filled. So this is what all about the Carnot engine. Now what is the Carnot cycle? The engine is operating on the ideal reversible cycle. That cycle is what we call Carnot cycle. So this Carnot cycle is between two reservoirs and is the most efficient engine possible up to now. Okay. Now suppose what I'm talking about the Carnot engine, I'll show you that this is your suppose source. Okay, source which is at temperature T1. Another is your one more is there. This is your insulating stand. Okay, so this is insulated stand, and then finally you have your sink. Okay, this is sink, and obviously it has temperature T2 which is less than the source. Now you have some cylinder, you can say, and as I already told you that cylinder has wall which is adiabatic, or you can say non-conducting in nature. Okay, so these walls are thick because of the non-conducting nature, but the base is conducting. And a piston is used here, frictionless piston. Okay, so this is what a piston is used. So you can say this is a cylinder with conducting base. And here your gas molecules are there. Okay, you can see these are the gas molecules, which we call them as working substance. Fine. So now it's very much clear what is working substances. Okay, so this is all about the Carnot engine. Now, what SEDI Carnot says that this operates through a series of the two isothermal and two adiabatic processes. We will see those, and these processes all over what we call Carnot cycle. It is a theoretical engine with which the efficiency of practical engine is compared. So we have to find the efficiency also. So we are going to enter in the concept of Carnot cycle now. And as we enter in the Carnot cycle concept, we will draw the PV diagram graph along with that. Now, what is happening in this concept? We are going to place the cylinder on the source. So your cylinder is placed on the source with a temperature, you can say, with the temperature of source as T1. Okay, so temperature of source T1 is there. Now what happened when we put the cylinder on the source, so that the gas acquires the temperature of whatever the source have, which we can say T1. So gas allowed to expand, and the gas allowed to expand, your piston will move upward. But this expansion is very slow. Okay, the piston is moving slowly, and the temperature of the gas, as the temperature of the gas falls, the gas absorbs required amount of heat from the source. Okay, and it expands isothermally. Clear? It expands isothermally. So if I draw the PV diagram for this